I'm just going to turn off some classes just to help everyone see it a bit better. Let's turn off our low and high vegetation. Okay. So when we look down the assessment in this cylinder style view, or this view here, we can see that the vegetation is color coded per distance from the conductor. So the closest vegetation is true vegetation, and we can see that this is actually vegetation here, and we can see that it's actually vegetation here. And what I'll show you is that if you turn off gradually, we can see that the vegetation turns off as it gets further away from the span. So I'm just showing you this to understand. Well, someone would like control. Is there something that Devanad would like to do? Should I, would you like to have a go at playing on the span? Is that?
I think it'd be best just that you remain control, Eloise.
Yeah, sure. Maybe it was an accident, no problem. Okay, so as I was saying, so as you can see, the vegetation class is removed as you get further away from the vegetation, and it goes up gradually. So you can see it goes 0, 1, 2, 3, 4, 5, and then from vegetation exception 4, it jumps to 0. So essentially what a user will always need to ensure, regardless of the project, is that if they identify in their particular assessment that they've got vegetation, we don't use vegetation 0 often, but if it is present in the span, that's concerning, as long as it is genuinely vegetation. But the main aspect of your assessment is ensuring that anything that is vegetation exception in your assessment is true vegetation. And so where the point of your assessment in span review is that if there's a false vegetation exception, that you reassign that LiDAR class to the correct class it needs to be. So just turn all our classes back on. Okay, and what I can see here is I have a false vegetation exception floating just here. So that is something that a user would need to look at and change to noise, because that is a classic example of a false vegetation exception. So when a user will open the span, that is the user's first job is to check all their exceptions, and I can see that one here, this should actually be a noise point, and it's been incorrectly assigned as a vegetation point, so it's come through as a vegetation exception 3 close to the conductor, so this would be required to be changed to noise. So a similar aspect to the way you use the tools in tile review, you can use the lasso, you can use the area, you can use the single selection of point, or you can use classes. For this I wouldn't recommend this tool, but you can grab this tool, select that point, and change it over to noise, and just save your edits as you go. What a user might feel comfortable doing is what we did before, which was turning off all visible points and only turning on your vegetation exceptions. So for here, we know that we've got true vegetation here and true vegetation here. We've got one point here, so I'll just turn on the next class, and then we've got vegetation there, so that's okay. So back to what I was explaining before about continuity, is that if you had a break in this assessment, you would know that that's a false vegetation exception, and that's why that continuity flag appears. So it would be that the span can see that it has vegetation proximity 2, 1, and then it skips vegetation proximity 3, and then it continues on to 4, 5, 6, and generally that will happen if there's false exceptions in the span. So I've got two users that, so Anand and Nityanand are both experiencing the screen being slow. I'll just wait for Anand, he's just typing. Okay, not a problem. I'll try and rotate slower just to assist the team members that are experiencing the slow connection. What about for the team members that are experiencing the connection issue where my screen is rotating slower? What about my voice? Is that also slow, or you can hear me clearly? Okay. Okay. All right. Perfect. All right. Well, I'll just try and slow down my screen then while I rotate. Okay, not a problem. Again, depending on your project, so for 8785 projects specific, the conditions of that project are only to ensure that vegetation is true when it's within exception and all the way through to proximity 4. So what users can do, depending, again, it will always change dependent on your project, is that you can turn off these classes and you can turn off high and low, because you know that you don't actually need to make any changes to those assessments. Similar to, so once you are happy with your vegetation and you content that all of your vegetation represents true vegetation, you can move on to conductors. For the purpose of this span, for what I would do here is that here we can see that this is classified as vegetation, but we know that a tree would never look like that. Unless it was a hedge, maybe someone could have trimmed it perfectly to look like this. But we know from the context of where this is located and it's in a suburban area that that is most likely a street sign. So this is something that you would need to change over because it is a false vegetation representation and it's very close to the span. So it's within the categories here. It'd be from proximity 1 to about 4. And so that would need to be changed over to the unknown feature code, I believe, for this particular project. So what you can do, similar to what you've been doing in tile review, you would grab one of the tools, select the features, and change it over to the unknown feature code. As you can see, there's a remaining part of the post that we're not obtaining, and that would be fine to, again, dependent on the project specification, that would be okay to leave the rest of the post in that particular category, because we know that the top of the post that was in this category has been changed, and what would actually happen is that after analysis, this would actually change. So be mindful of that, is that when you make changes and save and then analyze, which we'll get to in a moment, your vegetation exceptions change because you've changed the LiDAR classes, as well as if you made any changes to your conductors, which I'll get to in a moment as well, your assessments do change. So moving on from vegetation, I think I've covered most of what you'll need to do here with vegetation. So just remembering that the aim of the game for vegetation is to ensure that if it's vegetation, make sure it's true, and if it's not vegetation, it needs to be changed to its class accordingly. So for this case, we had a signpost that had to be changed because it fell within these categories. Sometimes you might get examples where there's vegetation in building, vegetation on pole, vegetation on conductors. So as I said, the aim of this and what is required is that any vegetation that is false needs to be changed over when it's within those category classes. So do we have any questions about vegetation before I move on to poles and conductors?
Yeah, hi Alois. This
Hello.
is Nikhil. Can you hear me?
Yes, I can, Nikhil. Yep, proceed, please.
Okay.
Ask.
Just want to understand, like, maybe I may have missed out. What is the difference between exception and proximity?
Yeah.
And there are multiple classes within exception and proximity. So, like, what is the difference between exception 3 and exception 4? And similarly, the proximity classes are also defined as 1, 2, 3. So, is that depending on the distance, like from one particular distance, it starts proximity 1, and then beyond that 2, 3, so on and so forth. So, if you can just explain.
Yeah, absolutely. So I'll start with the vegetation exception, and what I'll do to make it easier is turn off everything. So vegetation exception, when it gets classed into vegetation exception, it is to do with the distance from conductor. So actually, if I go here, it might be better. So these particular classes have been assigned into vegetation exception 3 and 4 because they are within the certain exception distance from conductor. So it's all based off distance to the conductor, and it's for vegetation distance to conductor. So it's based off vegetation encroachments that are set by regulatory bodies in Australia, because Australia has very strict bushfire regulation and control. So there are distances that are required to be assessed from the conductor. So distance from here to here is how this vegetation gets categorized into vegetation exception 3 and so on. So for this particular assessment, we've only got a small portion of vegetation within that close proximity to the conductor. There are vegetation exception 2 and vegetation exception 1 that aren't present in this assessment because there is no vegetation that close to the conductor. So as we go up in exception, it obviously goes a little bit further away from the conductor. Similarly, after vegetation exception 4, it goes to the first class of vegetation proximity, which is 0. So as we go up, we're moving further and further away from the conductor in terms of distance. So it's to do with our vegetation reporting that we provide once this assessment has been completed. So you can see here...
So what are the classes? Sorry.
No, continue, Nikhil.
So what are the classes that we have to really look for when we do a span? Like, is it only vegetation exception 3 and 4? And what are the classes that we have to review?
So every project will have a different specification. So however, for all projects, they are always concerned with vegetation 0 through to 4. So keeping in mind 0 is extremely close to the conductor, and then as it moves away it goes up in exception. So every project that I've worked on to date is always concerned about our vegetation exception classes. They always have to be accurate, and there can be no leniencies made for false vegetation exceptions. The next category that gets used is the from vegetation proximity 0 and beyond, and again it is dependent on the project. So the project will always specify which particular proximities they are concerned with. For 8785, they are wanting that all users ensure that if a vegetation exception or proximity 4 all the way to proximity 4 isn't vegetation, it has to be changed to the class that it should be assigned to, and then they're a little bit more lenient on proximity 5 and above. So it just depends on the project specification. Does that confirm your concerns there, Nikhil?
Yes, Eloise. Yes, thanks.
No, not a problem. So, as mentioned, it's just important for the team to, depending on whether they're on the transmission project for 3132 or the distribution project for 8785, that they clean and correct issues in the span, and they take the focus, depending on the project, whether the project wants you to be concerned about proximity or whether it wants you to be concerned about exceptions. So transmission has a couple of other concerns that is specific to that project, and that's what we'll go into tomorrow. So once your vegetation, once you're happy with your vegetation assessment, the next task for a user to address is the conductors and the poles. So depending on a user, they will get a feel for, I guess, the method they want to do. So some users might prefer to start with the conductors and the poles, others might prefer to start with the vegetation. It's entirely up to the user. So I've shown you the vegetation first, but by all means you can do that last. It's up to you. But for now, the next step we'll take is looking at our poles and looking at our conductors. So to make it easier, what I'll do is turn off the vegetation for now. Bear in mind that if you turn off the vegetation, you do just need to make sure that you don't have any false exceptions later, but I'll show you how to do those checks in a moment. So we have our, this is what most of you would have seen in Tile View to date. We've got pole, our conductor lines, we've got 2 circuits on this assessment, and we've got the GIS span line down here. So in tile review, I believe that unfortunately this line wasn't coming through for the team, but now it's here. So when you're looking at your assessment, you can click on your GIS reference line here, and you can go to attributes, and you can have a look at what this span entails. So this particular span has 11 kV and an LV. So we've got the top circuit is 11 kV, the bottom circuit is low voltage. We've got our materials of bare and bare, and it gives you a span length, and then this is the unique ID for that particular span assessment from pole to pole. What a user will need to ensure for their conductors is that the conductors have, so every conductor has its own attribute information, so you can click on these individually and you can have a look at the assessments. So for one conductor, what a user will need to ensure is that the voltage and the material and the circuit match what is referred to in our GIS span line. So if we start with our low voltage and our bare, we'll check the conductors, and they are all LV bare, circuit 1, LV bare, circuit 1. The reason why I know that this is circuit 1 is because it's the lowest circuit on the pole cross arm. So this is always considered circuit 1, and this is always considered circuit 2, and it goes up as the circuits continue upwards. So for this particular project for 8785, a user won't experience more than 4 circuits on the one span, and what a user will need to make sure is that all of these conductors on this one circuit are associated with circuit 1. What a user can do, if there was an attribute that the user had to change for these conductors, they can click on this, they can press Shift and select all the other conductors. They can update and they can copy attributes so that all of the conductor information gets updated at the same time. Similarly for our HV circuit, which is on our circuit 2, again it's circuit 2 because this is our circuit 1 and that is our circuit 2, and that its voltage is correct and that its material is correct. So in most, and again, we can highlight all of these, making sure that it's all 11 kV, there, circuit 2, and copy attributes. What a user might find is that, for instance, this particular conductor has been drawn wrong. So what a user will need to do in some cases is that essentially with the conductors, what a user needs to ensure is that the conductors are perfectly modelled to the LiDAR points. So everything has drawn automatically relatively well. I'm pretty impressed with the system here, except I've got two inconsistencies. We can see here that this conductor has drawn below what is true in the LiDAR. So can everyone see that irregularity there, that I've got LiDAR points here? I'll turn them up actually to make it a bit easier. So we've got our LiDAR here, and we've got our conductor here. So these conductors do actually have to... Sorry, Nikhil?
What's happening? Yeah, what's happening is there is a delay between your voice and the screen, and that's why we are finding it a bit difficult to understand it very clearly.
Sure.
When you are saying that you are selecting and we are getting that particular screen after a few seconds. I'm not sure whether others are facing the same problem.
Not a problem. I'll do my best to slow down, Nikhil. Thanks for that feedback. Okay, so this particular screen here, hopefully the screen has stopped moving for everyone. So what is occurring is that I've got conductors that have been drawn automatically by the system, and it is inaccurate to where the actual LiDAR exists. So we can see here that the LiDAR of the actual conductor is drawing here, and then our conductors have been positioned incorrectly. So what a user would need to do in this case is delete, and they would actually need to redraw those conductors, which I'll show you how to do that in a moment. So now we can see the screen that we've got 1, 2, 3 automatically drawn low voltage conductors, and we've removed that fourth one because it was incorrectly drawn, so it means that we will have to manually draw it. As well as up on our second circuit, our 11 kV circuit, we've got 1, 2 that have been automatically drawn correctly by the system, and we need our third conductor drawn again. What I can also see here that's occurring is that the LiDAR classification behind the conductors is also incorrect. So sometimes what you'll have is 2 fixes to complete in your conductors. You'll need to, 1, fix the LiDAR classification of the conductors, as well as 2, you'll have to redraw the conductors where required. So a hotkey that we've sent to you in the past is hotkey Z, and when I press that, it turns off my conductors, and then I can just see the LiDAR. And the reason why I've done that is just to show you that I've got a mix of LiDAR points where some have classified as either unused conductor or wire conductor, and then some of them have successfully classified into low voltage or into 11 kV. So again, what a user will need to do first is assign these LiDAR points to their correct voltage classification, and then they'll need to draw a conductor. So what I like to do to get this done quickly is that I'll go to top view, I will then make a clip from the pole to pole so that I can draw my conductors correctly. Again, you can do this just in regular 3D mode, but for starters, it might be easier for a user to just draw a window. And especially when you're doing edits like this, I'd recommend that you have your other classes turned off. And so now I can see all my points that I require. So what I'll do for this as well is that I'll turn the pole points off and the ground off. And then in bulk, I'll select all of these points that are incorrectly classified, and I'll change them to the low voltage class. It doesn't matter if you over select. If we're going at the right pace, is my voice matching my actions?
Yep. Yep.
Okay, great. So then I'll go over here, and Nikhil said no. Is it still slow? I was just waiting for Saga, just typing a message. Okay, there's maybe some issues today with the net speed. So hopefully everyone can see my screen as it is at the moment. I've just selected all of the incorrectly classified points that should be low voltage points. And the reason that I know that it's low voltage is because I had in the past checked this line here, our GIS line at the bottom, and it's telling me that I've got low voltage on my circuit 1. And so that's how I know that I'm executing the right task, because we can confirm it in our GIS line. So I'll just select those points again. And then I go over here to my classes and I tick the box here to change those all over to low voltage. I'll perform a similar action to my second circuit and I'll convert all those points over to 11 kV. Again, the reason why I know that I need to assign this to 11 kV is because I can know that from my GIS line that runs along the bottom to give me that information so that I know that I'm accurately changing my LiDAR points over to the class I require. If you came across a segment that didn't have, for instance, all of these points were incorrectly classified to wire, and you could see a voltage in here that you couldn't see in your used classes, a user would need to go in to all classes and they would need to find the correct voltage, which is all here. So depending on your assessment, you might have 33 kV, you might have 66 kV, 330 kV if it was a transmission assessment. So keep that in mind, that your used classes will only be the classes that are currently presented in your window here. And if that if that voltage was not in this assessment, you'd need to go into all classes to go in and find that. So just keep that in mind for all of your assessments when you're assigning things to building, to above ground feature, etc., that sometimes you do require to go into your all classes. And most of you would have experienced that in tile review, and so the same thing will occur in span review. So now that I have all of my features in the allocated class that they need to be in terms of I've got all of these LiDAR points in 11 kV and I've got all of these LiDAR points in LV, I can now make my conductors that didn't automatically draw from the system. So I've got one to draw for the LV and I've got another one to draw for the HV 11 kV. So to make it easier, what I can do is just turn off the class that I'm not using, so I'll turn off 11 kV and I'll draw the low voltage conductor first. So with the conductors that are present for the 11 kV, we can't turn them off while we're doing this. They will remain, but you can turn all of them off and you can just view your LiDAR points. So you can do that if it's easier for your field of view, but if you wanted to know which conductors already have this catenary vector made, you can turn it back on. So to make a catenary, the system actually only requires a small amount of points. It only requires 3 LiDAR points to actually make these 3D vector conductors. So we can use any of these tools here. We can use select by lasso, we can use select by area, or we can use the select single. I'm just going to show you by using select by area. So you can grab, it's best to grab an even proportion of points, but I can grab a couple from the top, a little bit here, a little bit in the middle, a little bit there, and a little bit there. So that is all you would need. You probably could actually create the conductor with less than that, and you just need a portion of points for the 3D model catenary to accurately draw across the LiDAR points. So as you noticed, when I started selecting these points, these 3 tools popped up. So for span review, all we need to do is use this tool here. It's called Create Conductor. So once you have the LiDAR point selected, this tool will be enabled and you're able to create a conductor. You don't have to worry about create crossarm or create pole shaft, because that's for pole review, which is not the task that we're doing. So we're doing span review, so we only need to worry about create a conductor. So what I'll do is, once I have these points here selected, create a conductor, and as you can see, the conductor has now drawn perfectly to the LiDAR. And that's what we want to see. You can see this one here is slightly lower than the LiDAR points. So that is one as well that we actually need to redraw as well. So then another way you can draw your conductors is through this view. And you can go delete this one here, grab a box, and just draw a big box over all the LiDAR points. That's another quick way to do it. And then select Create Conductor over here, and then our conductor is drawn. What you'll need to do next is that because you've created 2 new conductors, you just need to make sure that their attributes are correct. And fortunately, it's all come through correct, so it's assigned itself to the LV voltage, the correct material, and the correct circuit. And I'll just check this one as well. And again, it's LV and it's bare, which is correct, and it's circuit 1. So then, after you've done that, we can move on to creating the conductor for our 11 kV that we had to redraw. So again, we've got the 11 kV starting here, coming all the way through to here. I'll grab my select by area, go over the points, and again press Create Conductor. So when I go and now select that conductor, again I just double check all the attributes have come through correctly. It's assigned itself to circuit 2, which is correct, material is bare, and the voltage is 11 kV. Then I'll have a look and make sure that all my conductors look accurate. So this is exactly how your conductors should look. Again, as mentioned before, your conductors need to model the LiDAR. In exceptional circumstances, you might have cases where the conductor doesn't perfectly model the LiDAR, and that's just due to the constraints of the system itself, so that's okay, but you won't have too many of those. But in any case, if you did have any concerns, you could always send us through some screenshots of particular issue spans. But in most cases, your vectors here, your vector conductors, they will always perfectly model the observed LiDAR. And that they are the two main requirements for your conductors. So ensuring that the LiDAR underneath is in the correct classification as per the GIS line. So again, we know that this span has LV and 11 kV, so we ensure that our LiDAR points on our bottom circuit are LV, which they are, and then we ensure that our LiDAR points on our top circuit, our circuit number 2, is 11 kV, which it is, and then we ensure that our conductors are matched accordingly, which they are. And again, we can check because we've got voltage LV, material bare, and we've got 11 kV for our voltage, so we know that our conductors have all drawn correctly now, and they are all matching all the way back to our GIS line, that everything is matching. Any?
Yeah. So if you click the GIS line, so for both the levels, it will be a separate thing that we will be knowing, or how do we identify that? I missed that part.
Sure, so that's how do we identify if something is circuit 1 or circuit 2, is that correct, Nazar?
Yeah, yeah.
Yep, no problem. So in the GIS line, if you see here, see how there's this, what we call a pipe, this separator between 11 kV and LV?
Yeah.
So I guess it's read almost backwards, but the first value here, 11 kV, will always be the highest circuit, which in this case is circuit number 2, and the last value will be the circuit number 1. So sometimes you might have an additional pipe. So sometimes you might have 3 circuits, sometimes you might have 4 circuits. In this example here, we only have 2 circuits. So the lowest one here gets circuit number 1, and the highest one here is circuit number 2. And then if you obviously had another one in front of this, it would be circuit number 3, circuit number 4, and so on. But rule of thumb is the lowest value here is circuit 1, and so that's how we know then here this is circuit 1.
Okay, so when you select the GIS layer and accordingly when we select the conductor of it, you get the value.
Yes, yeah. So you get the if you select the conductor, so this is the conductor that I'm selecting now, we can see that it's assigned to circuit 1. And then if I go back to my GIS line, now I can see that LV is the lowest attribute here, so that means it's circuit 1.
Okay. Will there be any concept from left to right or right to left, the flow of conductors? Conductor sequences, I mean to say.
So for here, for left to right, is that what you're referring to, is it?
Yeah.
Yeah, so the furthest one to your right is always circuit 1, and the furthest to your left, I guess, is always the higher circuit. So this one here, because it's the furthest value to the right, separated by this pipe, that is circuit 1. Does that answer your query? It's also in the manual that the team have got, there's an explanation. Yeah, not a problem. There's an explanation about how the lowest circuit up here on the crossarm is number 1, and then the second is number 2. So you can obviously visualize it here in the LiDAR as well, and that's because we can see that there is no conductor underneath this LV span. Sometimes you will get Telcom running underneath the LV, and for this particular project we're not assigning LV to a circuit, and then we've got our crossarm here, which identifies that we've got circuit number 1, and then we've got another cross arm up here which identifies we've got circuit number 2. So it all works upwards, so circuit 1, circuit 2, circuit 3. And there's a really good diagram in the clearance manual, I hope it's in there, so that the team can get familiar with circuit numbers.
So typically it's a bottom-up approach.
Yeah, correct, yeah.
Out here in particular, we see like 3 lines or 4 lines in the main span itself, but supposing if there is a connectivity where there is a single span line, or maybe a span line that has been linked through the main span,
Yeah, right.
So how do we figure out that, whether that's actually a span we need to work on, or whether that's just a service line?
So the conductors that a user will need to work on are the conductors that are directly above this GIS span line. Yeah, so that's your,
focus on the GIS line data itself.
Correct. Yeah, correct. So what you'll find is that if I turn on, okay, perfect. So then, so that's going into the next kind of element of the span that a user needs to assess. Where you see this occurring, that it's continuing on to another span and the continuation here, all of these LiDAR points go to code 14, wire conductor phase. So the only conductors, and I guess the span that is required for assessment, are the conductors that fall on top of this span line. And anything else?
Just one question.
Yep.
There are classes also, the LiDAR data also classified into circuit 1, circuit 2, or 11 kV and LV. Is there a possibility that those LiDAR classes may have wrongly classified, so we have to reclassify them and then draw the new circuit? Is there a possibility of we doing that?
Yes, absolutely. So that's what I was showing the team just now, is that we were reclassifying the LiDAR because the LiDAR was incorrect, and we had to redraw the conductors because our conductors were also incorrect. So the users will be looking at a assessment that has been automatically processed from our system, and for different reasons it's been flagged that it needs to go for a manual intervention, so someone to manually look at the assessment, and that will include that the user ensures that the conductors are in their right classification, which will either be LV, 11 kV or 33 kV, depending on the GIS line, what it specifies, and then they will make their conductors accordingly. So you may not have been able to see my screen earlier, but that's what I've just been showing the team. It's exactly that, changing the LiDAR points per the GIS line, as well as creating conductors where the conductors were incorrectly drawn by the system.
Okay.
Yeah. So then leading into Nozer's query is that we've got, I guess, adjoining spans that lead on to another span assessment, and for all of those wires, they will all go to wire conductor phase 14. So what I'll do is remove this clip, and I'll show you about cleaning those. So we've got here, we've got some of the pole that's misclassified to wire. Cases like this, you do a little bit of a tidy up. You don't have to focus too much attention, similar to tile review. As long as there was no exceptions here, we're quite happy. But what I do here as a user, I just grab this lasso tool and I do a rough selection of the wires in my field of view. I'll just rotate. I'm just going slowly because I'm mindful of the lag. I'll just do a rotate to make sure that I haven't accidentally selected a point I didn't want. And then those points I've selected, I will change them to wire conductor code 14. Then check any of the adjoining spans here. So this one here has already been classified into code 14, so that one is okay. I've got one over here that's been classified as vegetation exception and proximity, so this is one that I would definitely need to clean. And then I've got some here that have been classified into pole. So for these, I'd go through and fix them as well. And sometimes it's just about getting on the right angle so that you can select all the points that you want in one go, so that you don't have to continually move your screen and your field of view. So I've got one little noise point there, so I'm just going to turn that noise point off so I don't select it, and I will select all of the wire that I can select in this field of view. Again, I've done it. Oops, I'll just do that again. As you can see, I'm just going to the edge of the cross arm. I'm not zoomed in all the way, and I'm just selecting what I can in this field of view. Granted that there are no vegetation exceptions. I'll just make sure that point there, that's a pole, so that is okay. That close to the pole is okay. So similar to tile review, where we mentioned to you that where little bits of the pole and wire intersect on one another, and you might get a bit of the cross arm classified as wire and vice versa, where we're not going to be too rigid or restricted on that for the team, because we don't need the team to be spending too much time for where the intersection of pole and wire occurs. And we'll select all that, change it to wire. And then here, what we can do for this one is that would be probably about right. I'll just turn off the ground to make sure I don't select ground, and I'll select all of this here and change this to wire also. And so that is our poles and our wires, conductors completed. What we might do over here is that we've got a wire inserting into vegetation here, and that's okay. We can leave that as pole. We just want to make sure in this scenario that true vegetation, if true vegetation was on these wires here from the pole, we'd want to make sure that they were classified as vegetation. So that's just one thing to be mindful of those intersections where there's most likely a stay wire going down into the ground here that the rest of it hasn't been picked up. So in this case here, I'd actually want to change over these 2 points that are pole. Because they are actually vegetation, I want to ensure that they are changed over to vegetation. And what we can do is just put it to high vegetation for now, because the analysis will reassign the vegetation classes according to the location of conductors. And the rest of that is okay. And then for the purpose of the project for 7785, what I'll do is just turn off, 8785, I'll turn off the vegetation proximity classes for this project specification that we're not concerned about. And I'll just make sure, I'll do a final check to ensure that all vegetation in these classes is true vegetation. There's a final check before I press Analyze. And then the other check that I'll do before I press Analyze is a ground check. So what's really important with ground is that it's good to just turn all your classes off, turn on your ground, and what you want to ensure is that where there are ground points false above ground, they will need changing over. So we can see here that I've got these points here that the ground, we know that the ground isn't undulating and going up a hill there, so that would need to be changed. This would also need to be changed because that's in through the vegetation. And then we come down here and we can see that we probably need to change some ground points here. So once I establish where the ground points need to be changed, you also need to turn on model key points when you're changing ground. But what I will do is just turn on other features to give me context for where, what classification the ground needs to be changed into. So here, all this ground can go to vegetation. And this ground here can also go to vegetation. Again, it is dependent on the project specification. If the specification wanted you to delineate particular buildings, it would need to go, this would probably need to go to building, but because the specification permits, we can change this ground to the closest class that it's located to, which is vegetation. So that was these features here, this here, and we can do it all in one go. So you can select all the points you want to change over. I'm going to leave this here though, because that was about ground level. There's a little bit of vegetation there, so I'll change that over to ground as well. And then here we have vegetation in the back, so that will also go to vegetation. And again, because analysis will change the vegetation exceptions based off distance to the conductor, I will just put this to high vegetation. It won't matter whether you put it to low vegetation or high vegetation, so that can go there. Turn on all my classes again. And then I am ready for my span to be reanalyzed before I submit. So at this point here, this is where I recommend the users to go through the checklist per project or through the manual that we've provided. There's 2 checklists there, and it will go through all of the features that you needed to be ensured are being checked. So for, as mentioned before, your main things are ensuring that vegetation is true vegetation, where you have vegetation classes. If it isn't true vegetation, so if it's false vegetation, you need to change it to a logical class per the specification. So whether that's changing the feature to building, to unknown feature code, or to miscellaneous feature. You then need to assess your conductors, ensure that your conductors follow the LiDAR to truth, ensure that your LiDAR points behind the conductors are also classified, ensure your poles and then your connecting wires are classified as well. So once you get to this point, we can save, and then we hit the Analyze button for the system to do the analysis again. So I'll press that now, and I can take any questions while we're waiting for that to analyze. Any questions about what we've just been through? I know it's a lot to take in, but hopefully that what I've showed you now, once you're reading through the specification and the manual again, things will start to consolidate and you'll start to remember, oh yes, that's what Eloise did in the tutorial. Any comments before I continue?
I think there has been too much of lag per se from the screen, but nevertheless, once we start playing with that, this kind of data itself, trying to work with different areas, what we have just spoken about, that's how we get more questions. And certainly this span review has requires more deeper understanding of the project specification, so we need to take a little deeper dive for sure.
Yeah, no problem there, that's fine. So once your analysis has occurred again, so the reason why I know it's occurred is because it's loaded for me now, and as well as I can't analyze again. So if I came to this point, again, after you reanalyze, it is recommended to go through your checks again because the vegetation exceptions change after analyzing because we change the conductors. So everything is based off distance to conductor, and because I made those changes to 2 of my conductors, my vegetation exceptions would change accordingly based off distance. So after you've finished analysis, it's recommended again to check your vegetation exceptions. What you will see are these little bulbs, and that is data that you can click on, and it gives you the exception distances if you wanted to know and the type of exception that it is. You will always see these little bulbs, these little circles, when you have a A1 vegetation exception, so it would be vegetation exception 1, and they are really, really handy for a user to see if they have a vegetation point on their conductor, because it will be followed by one of these shapefiles on top of the vegetation exception, so that a user knows that they need to change that LiDAR point before they submit. So if we go down to this point here, this is our closest exceptions that we have, and that's okay to submit because it's a vegetation exception 3, and it just highlights to a user that, you know, have a look at this, you've got this exception here. It's to provide a user with guidance, just in case they missed a point of vegetation on the pole, on the wire, on the conductors. It'll make those points bigger for the team to see them clearly. So once I'm happy again, I've just done a quick look, and everything looks exactly the same, except we would have had some changes happen over here, and that's fine. These cars, they can all stay as low vegetation because they are not within any of our said classes for this project. And then this is fine as well, that this has remained with the top part being classified to the unknown feature code, and then the bottom of it being vegetation 5 and 6. What we can do is just double check. We can turn off 5, and as you can see, the vegetation turns off, and that's okay to submit. And as mentioned at the beginning, every project will have its own specification of which vegetation classes it wants you to assess, and then you will clean your span segment accordingly. The other thing I should note is that after you have done your analysis, you will see all of your classes that are present in the span here. They are all here in our use classes. So what a user can do before they submit their span assessment is they can go over here and just double check that they don't have any addition to vegetation exception 2 or 1 within their assessment, and if they did, what they could do is just turn everything off and only turn on those exceptions to investigate them after analysis.
Eli, this is Nikhil. Couple of questions, like what actually happens when you press analyze button? Does it reclassify the cloud in terms of exception and proximity based on the conductor change?
Correct, yeah. So what I was mentioning before is that once you've hit analysis, because we changed our conductors location, so we deleted 2 conductors, and this we redrew them, this means that the distances to those conductors have changed. So after analysis, what changes is the vegetation classification. Sometimes it's very minimal and you won't notice a difference. However, in some cases, if all of this vegetation was classified as wire or pole, you'd obviously see it now classified into proximity, and vice versa. If you had removed false vegetation exceptions, they will then be removed because you would have reassigned that class to the wire that it's meant to be, or the voltage that it's meant to be. So analysis reassigns the vegetation based off distance from the conductor, and that's what I was mentioning before about the ground when I was changing over the false ground to vegetation, and I said to the team that we can put it to low or high vegetation, it won't matter, because the analysis will determine which classification it needs to be in. So a user doesn't need to worry about changing, so when they have features that need to be vegetation that have been incorrectly classified, a user does not need to worry about assigning that vegetation to vegetation 4 or 0 or 1. They can just assign it to high vegetation or low vegetation, and the analysis will assign the vegetation based off distance from conductor. So it makes it a bit easier for the users that they don't have to worry about assigning vegetation into all of these classes. The system will do it for them.
I think that's a good point. So analysis, by pressing analysis, the LiDAR data gets reclassified.
Correct.
So is there all the more reason that we should first check the conductors, make sure that the conductors are at right place, and then we start with the exception and the proximity? Or the alternate question could be like, is there any sequence that we need to follow so that we don't need to revisit exception and proximity vegetation post and pre of the conductor validation?
Yeah, absolutely. A user can choose to do their poles and conductors first, absolutely, before they look at their vegetation exceptions. However, once they've changed vegetation exceptions, they will need to reanalyze and save those changes. So it will be entirely up to the user. The checklist, I believe, goes through conductors, poles, buildings, vegetation exceptions, then saving and analysing, and then rechecking your vegetation exceptions. But as the users get more confident, they'll decide to approach the span in whichever method they want. But a user can, if they wanted to, do one round of saving and reanalyzing after conductors have been changed and created, and then go through everything. It's entirely up to you. By default, I go to vegetation exceptions first, and I remove all of the false vegetation exceptions first. I then move on to poles and conductors. But again, it's up to the user. They might want to go to their poles first, and then their wires, and then vegetation. It's entirely up to a team member.
Okay.
Yeah, but there's a checklist so that a team member ensures that they have done everything. And I guess it'll be up to them what order they want to proceed with.
Okay.
Not a problem. So I would be happy to submit this span. So similar to tile review, once you are happy to submit, you hit complete. I should also mention, so this is an example of an assessment that we would be happy to complete. What users may find is that they need to exclude an assessment. So there is guidelines on how to exclude and where you could exclude. So what I'll just do here, I know that we're running over time, but I'll complete this assessment and then I'll quickly go through exclusions. And I'll do my best to explain them as I can. Sometimes it's more trickier with exclusions, and our main reasons for excluding are if the GIS line is incorrect and if there's insufficient LiDAR to actually create the 3D conductors successfully. So I'll get to that in a moment while we wait for this particular span to go through.
One question.
Any questions so far about completing?
Yeah, well, there is one question out here regarding creation of conductors. Certainly, you pointed out very correctly if there are points insufficient, or do the conductors need to be up to the cross arms, and if the points are less,
Yep,
or if there are no points
absolutely.
that are connecting the cross arms.
Yeah, absolutely. And I'll hopefully this span that I'm going to open might be a troublesome one. So, oops,
And
there we go.
typically, I have two more questions actually. In one tile, as we experienced during the tile review, there could be multiple spans in one tile itself. So, while doing the span review, also will we come across a similar situation, or it will be one span in a tile?
Yeah, so with span review, it will always be just the one span. So a pole-to-pole example, as you see here, this is another example. So it's always just pole to pole, and then the assessment that is required is anything that sits above this GIS line. And this is a good example because you can kind of see that there's lines and wires going out to other spans. And that was just about your question that you had earlier, Nozair, about what you do with these, and they all just go to a go-to wire. So,
And
so
if there is a pole or a ball pole or something, because a lot of our guys had a confusion between ball pole or ground stays or something, because to our
yeah,
understanding, typically a ground stay connects to the pole halfway down the lines and not completely from the place where the cross arms are. But what we observed is, and the feedback also we got from that, we had certain poles classified as cables, and cross arms were actually, like for instance in this case itself, if you see, the cable is actually connecting through the cross arm and not in
yes,
between. So would you consider
yeah.
this as a cable with a pole, or it is going to be considered, the entire part is going to be considered as a part of a pole?
For this particular project, if a user classified all of this to classification 15, which I think a couple of users did in this project, then that would be fine. As you can see, it is coming from the cross arm, so it would indicate that there is electricity running through here, and it potentially is going down to an underground connection.
Yeah, so it could be a
So
ground connection or something.
yeah, correct. So a user could, as long as there were no vegetation exceptions, that's the whole point of this, that if a user kept this as code 15 and then change all of this to code 15, that's not going to be a fail. If a user had chosen to change all of this to code 14, that's also okay for this project. Neither of those options are going to be a fail.
And if we, I'm talking particularly in this context in regards to the tile review that we were doing. So we wanted a clear understanding on that, so that all of us could be on the same page, because we came across a lot of poles and we were like unsure which one to classify as a pole and which one to go ahead and classify as, cable and
Yeah,
all.
yeah, absolutely. So the understanding the confusion from your team, have seen both come through and have passed through both options, and I had actually seen one where I thought it was an aerial overground stay, and then realised that it probably is this underground connection because it does connect up to the cross arm. But in any case, as long as either option, whichever option the user chose to do, both were passed because there's no vegetation through here, and that's the main thing for when things are sitting close to this span. This is not going to get its own assessment. It's just an additional feature for this particular assessment. So your main concern is here, and these features up to the side, as long as it didn't have vegetation exception, it is fine. Obviously, in a case like this, you would put that to wire, and you would put this to wire, and you would put that to wire. But these occurrences where you've got this either ground stay or this wire connecting to the underground connection, we weren't going to fail the team for whichever option they chose.
I have one more question regarding the cross arms. We had got the feedback on the session file, like there were a couple of towers where we misclassified the cross arms as conductors. So I believe in the last call that we had with Tad, I believe you were not present at that point of time. Tad mentioned that it is okay to classify some points of cables into towers rather than
Yeah, yeah, absolutely.
orbital. So what we are doing is we are taking a cross section or a section of the tower, and we're trying to select more points into cable points, conductor points into towers to avoid that issue itself.
Yeah, 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 that's fine. And I was actually mentioning to the team before as well that where you've got that overlap and that intersection of your cross arm through to your wire, a couple of points here and there that get misclassified as either, that is not a important requirement for this particular project. What they are mainly concerned is that if you left this vegetation point as that feature. So they're the main concerns. So yes, Chad is correct in what was informed, in that where you've got that crossover between the two classes, that is okay as long as there's no vegetation points.
The question out here actually was, there were certain towers, like there were high voltage lines, low voltage lines, like the span review that we did for the earlier tile. There are certain poles in which there are cables connecting from first level to second level and second level to third level.
Correct, yeah.
There's a possibility of cables, but we can't really identify from what point to what point,
For sure, absolutely,
yeah.
yeah,
So
yeah,
we are
yeah.
just classifying all of those points also as stars as of now.
Yeah, absolutely. So yeah, the classifying to code 15 is the correct approach, and that's, I believe, what I've seen as the team have been doing. So that's correct on as far as we're aware. That's the correct what we want to see.
Okay.
Yeah. All right, so I know that we've gone a little bit over time, but I will just quickly show the team about your first questions that you had there, Nurza, which is just, how do they know when to exclude and if the conductor is matching up to the LiDAR and so forth. So what a user can do when they first open an assessment is they do need to do a GIS check. Sorry for not informing that earlier. So what they need to do is ensure that the end of this GIS point here is within a 0.5 metre tolerance to the bottom of the pole. And similar here, you can see that it's within a 0.5 metre tolerance to the bottom of the pole. So if a user is, if this GIS line appeared over here, away from the pole, a user can actually get out the ruler and measure. But for this case, everything is looking accurate to me. I can see that my GIS line is finishing at the pole base, and I can see that the GIS line finishes at the pole base here as well. What you may experience in some cases is that your GIS line is really, really far below ground. And it's just to do with our processing that it hasn't picked up the accurate Z value. So because we're in 3D, we have X, Y, and Z. And so sometimes the Z value gets assigned to 0, which is in some cases is well below ground. So what can occur is that this GIS line can be located all the way down here. In some instances, it might even be located on a slant. And that is okay. It's just a processing error that we commonly see. What a user can then do instead is they can check their GIS line using the aerial view. So they can go into this view, and then it won't matter where your Z value is located, because you'll be able to determine that my pole is accurate here to the end point of this line, and my pole is accurate here to the end point of this line. So this is definitely within acceptable tolerance. What would not be acceptable tolerance is anything outside of 0.5 of a metre. So where that occurs, so for instance we've got the ruler out, if your GIS line, for example, was located out here, and you could see, okay, it's 1.93 metres away from the pole, or in another case, it could be located here, and you can see that your pole exists here in the LiDAR, but the GIS line continues past the pole. What a user would need to do is fail this assessment and exclude for GIS incorrect. So they would go here, and that's fine, we can go yes, and then the decision would be excluded, and it would be GIS incorrect, and then they would submit. So a user, for these cases, a user does not need to make any other changes to the assessment, so it's actually good that your GIS incorrect and your GIS check is done first, because you don't want to do a whole heap of work and then you end up excluding the span of the GIS incorrect. So for GIS incorrect scenarios, the user just needs to check the assessment location of that GIS line and then exclude for GIS incorrect. The classification does not need to be changed. Conductors do not need to be drawn.
Alois, like in tile review, there were many tiles wherein either the AOI layer was not present or the point cloud data was not present.
Correct, yeah.
For such tiles, we would be asked to complete a tile. So I believe that rule applies out here as well.
So what will occur is if you opened up a span assessment where this line didn't exist,
yeah.
reanalyze
GIS layer. Can you help me with the layer name to look out for?
the GIS line. So it's the span line. So one moment.
It would be in the layer list, right?
Yeah. So it's span. So if I go layers, it's this one here. Sorry, span. It's already turned on.
Okay.
Yeah.
Just says
So
span.
so you could check if it's here, and then if it wasn't there, you could turn it on. What you could do first is, if you couldn't see this here, you would reanalyze. If you still couldn't see the span line, that is something that you would then exclude as well.
Okay.
And you would do it for GT to check.
What does GT stand for?
GT is just a legacy name for the
Geospatial
software.
Technologies, yeah, geospatial.
Correct, yeah. So it'd be GT to check. A user could also use other, and they could specify span line not present. You shouldn't have that happening in span review, and if you were to have that, you'd exclude it. But what you would need to do first is analyze before you exclude, because sometimes it just takes a secondary analysis for that to come through. It does not happen often, and there's usually some other error at hand if that hasn't come through in your assessment. So that's for your GIS check. What a user will see as well is that the entire span comes through misclassified. So this is where it really pays for a user to make sure they check this line, which is LB bare, so that they know what LiDAR this needs to be cleaned to and what conductor it needs created. So for this example, a user will need to clean all the LiDAR points and create all of the conductors. And so these are the particular spans. They take a little bit longer for a user to complete, but they will come through. And if they have the same requirements as all the other spans, it's just the system wasn't able to automatically populate things for the user. So you'll have 4 conductors to draw, and you'll have all of these LiDAR points that you need to classify. Once you clean all the LiDAR and then have your conductors, and you press save and then you analyze, automatically all this vegetation will change to proximity because it will have the conductors drawn. So just keep that in mind, that you will see a change in your assessment because the conductors will be drawn and the span will be analysed with conductors, and then all of the distances will apply later on. So this would be a good example, something that Nikhil was mentioning earlier, is that when you have cases like this is when you would want to draw all of your conductors first and classify your LiDAR points first before you did anything else, because after you save and reanalyze, that is when all of your exceptions will come through. So keep that in mind for assessments that look like this, where there's no classification of the LiDAR and there are no conductors.
So Lois, considering all the checks that one needs to make, typically a person who is well versed with the specs, obviously that will come with time. The more tiles a person works with, and once a person is through with the spec, ideally, what would be the time one person would spend on a tile of this kind, cleaning up the complete span and digitizing it completely? Because out here I can see all the work has to be done right from the scratch, I guess.
Yeah. So I'd say for an intermediate to and it will take time for your team knows there. We're not expecting that the team will be expert users to begin with. But for
it scares me because earlier while we were working on the tile review also, I learned from you or Tara, I don't recollect correctly, saying that it would take 25 minutes to 40 minutes per tile. But then when we started working on it, we realized that we're taking nearly around 2 to 3 hours per tile actually, considering both the processes, review assessment as well as check assessment.
Yeah, absolutely. I'm sure that you and the team were concerned then once you started working and you had 2 hours and 3 hours, but we understand that you're new users to the software, and we understand that time is going to be it has to be a little bit more lenient, especially at the beginning. I'd say that a beginner user would probably take around 25 to 30 minutes to do this. It might even take longer for a complete first span. If it was a first span that someone looked at, they might even take up to 40 minutes to do this one. However, that's acceptable for a user's first couple of days. Once a user would become experienced, this particular assessment shouldn't take more than 15 to 20 minutes. The other assessments that have a lot of automatically drawn conductors and automatic classification, an intermediate user would take about 10 to 13 minutes per assessment.
So, Eloise, Anirudh here. I just have a very generic query. So, there are smaller spans and there are longer spans, right?
Correct. Yeah, correct. So there'll be
typically for the longer spans, how much time do you anticipate for an expert and for a novice?
For the longer span, so depending on the span length, I don't foresee that changing the time for a user, because a user should be able to, it won't matter if you had all of this to select or all of this to select. You can select things in bulk, so you shouldn't have an extraneous amount of times depending on span length. I've never had that experience to date where it's taken a user longer because of span length. Where a user will accumulate their most time is just dependent on what the system automatically populated and what the system hasn't automatically populated. So if a user had to do all of the LiDAR classification and conductors, you'd expect around that 20 to 25 minute mark for a new beginner. For an expert user, I'd say it would take them about 15 to 10 minutes. Where the system has done all of your conductors and all of your LiDAR classification, that's where you'll have your 10 minutes. So I don't foresee a user experiencing longer time due to span length. A user will have longer time when there's multiple circuits. So when there's a single circuit like this, it's a lot easier for a user than when they've got multiple circuits. So if they had, on top of this, they had 11 kV and a 33 kV to clean. So and the ones that are like that, so if you had on top of this span with misclassification and no conductors, if you had LV and then a 11 kV and then a 33 kV, so a user was dealing with 3 circuits, you'd probably see that your new users would probably take about that half an hour to 40 minutes, so an extra 10 minutes to ensure that those other conductors are drawn for a new user. But once your users start to get more familiar with the software, you'd expect that they'd all reduce down to 25 minutes for cases like this, regardless of how many circuits are present. Would you say that's about right,
So that
Chad?
includes, sorry. So that includes the check
Yes.
assessment and review assessment as well, right?
Oh, sorry, I'm just talking about production assessment. Your check assessment will be dependent on your QA team and how confident they feel. It can range from 2 minutes, 3 minutes, up to 10 minutes, depending on how much they have to change or check.
Yes.
Yeah, as the team becomes more proficient, the QA, the QC team will take less time to check over the work.
Yes.
That's
Hopefully.
true. I agree.
So what I gather, there are a few good practices that anybody has to undergo. Number one, go through the manual very, clearly, so that each and every aspect of the number of features in the table of content is very clear. Number two, the way Nikhil told, that one should prioritize, these are the items we should go first with the conductors and the poles and then the vegetation.
Absolutely.
So that's our internal way of how we do, but still you have given your, high level understanding what are the best practices, followed by, what are the precautions that we need to check and the very frequently occurring problems, which we need to take. And then we need to probably increase our respective bandwidth wherever we find that there may be a lag from connecting through our own networks. And these are some of the elements hopefully will help us to increase the speed and the
Yeah.
familiarity, of course, and experience.
Absolutely, yeah, absolutely correct. Yeah, it'll change over time as well. You'll see your team will, once they've done, their first 10, it'll be a breeze for them, I'm sure.
And I strongly advise going through the specification manual as well, the checklist that Eloise was talking about at the start of the meeting, outlines exactly what best practice is.
Yes, and so far we have been doing it in the tile review manner. So when is the tile review process ends and the span review process starts? Is there any timelines or the number of, how do you want to make this transition?
So we will allocate a session to you, and but I think for today, I think it would probably be best to open up a span, but just and play with it, but don't complete anything. Just release the work that you've done, and then tomorrow morning I will allocate a session for you. So your QC team will finish off tile review today, tomorrow, and your review team can go straight into span review as of tomorrow morning. But yeah, I recommend just reading over those two manuals, the generic span review manual as well as the 8785 specification manual as well, and opening up some spans within that project, but don't complete anything or fail anything. Just do some work and then release it. And that will hopefully get you up to speed, ready for tomorrow morning.
Okay. Tad, one question out regarding the tile review per se itself. So, as you informed earlier, all the tiles have gone missing from the review assessment. There are some tiles in check assessment. Just in case the tiles are not complete and if they have failed, they will be moved back to review assessment or rework. So, how do you want us to address that? Should we fix those, or
So the review tiles won't be there anymore, but what will be in check is what's failed audits. and then we just finish off those ones in check, and we'll move on to span review, which is more of an urgent priority right now for us.
So, Nazir, what you can ask your production team to do is that rather than failing the check, just to clean it themselves. If that's what your concerns were, that it's going back to review, you can just get the team to, because if the production team are all learning this new specification and they're testing, they obviously won't go back to review for tile review. So if you just ask your production team to complete the changes themselves rather than failing the check tile, sorry.
Okay.
Yeah. I think it sounds like we're wrapping up here, but just one final thing I just wanted to quickly show everyone. It's very obvious to notice when a span should be excluded for insufficient LiDAR, and what will happen is that you will have almost no conductor points between your two poles. So that is would be like examples. This is not an example at the moment, but it might look something similar to this, where you've just got one pole, a small amount of LiDAR here, and you've got a small amount of LiDAR there, and so it's insufficient LiDAR to create those conductors. So keep an eye out for those assessments, because they will come through. And again, if you had any questions about whether something had insufficient LiDAR or not, you can always send us through screenshots, which you've been really good at doing with raising your questions through tile review. But it will be a case-by-case basis, that sometimes you will have assessments where you've only got two poles that you can see and there's little to no conductor points between the two poles. And they are those examples of where you would go fail, yes, and then you would exclude for no or very few LiDAR points visible. And that concludes the types of exclusions that you'll need to look at. So it'll just be where GIS is incorrect, no or very few LiDAR points visible. If you had those other pending concerns that we spoke about earlier, Nazir, when if there was no span line after you reanalyzed, you could go GT to check, or you could go other, and then you could go no span line present. Sometimes after analysis, you might get an exit code, and you could always put that exit code in as well. You can go exit code, 53, whatever it might be that's popping up. That stops you from completing your analysis.
Does that make sense for everyone?
Yeah, I think so. Once
Yes,
we start working on this,
Yeah.
we'll have more questions to come in, because there's too much things to drop. And
Of course.
The more we play with it, we should have more questions.
Yeah. So
That's right.
do you have all 20 team members for transmission starting today, Nazir?
We do have the names as such, but I just have to watch out, like now, since the tile review process is ending up, we just need to clear whatever the backlog is.
Sure.
I believe there should not be more than 100 tiles left over.
Correct.
Which will take, because honestly, the check assessment is being managed currently by 2 or 3 people only, not everybody.
Sure, no problem.
Yeah, so we'll need to see the amount of work that comes into those tiles to clear the backlog. If there is more work, then definitely it will take some time for 3 or 4 guys to finish all of those.
No problem.
The rest of them could be moved to the span review or transmission line project per se as such.
Okay, so what I'd recommend, the reason why I was asking is because I was going to show the transmission, but I will hold off for that for tomorrow. So if you have any of your transmission team that want to use and test, they can use their own login. So just say they're assigned login SR14 or SR15. They can use their own login on a workspace in the 8785 environment, and then they can go here and have a play around with the spans that are here. So that's something that's okay to do. You can have 2 users on one workstation at a time, because I know that you won't have enough workstations for the amount of users that will be testing, but hopefully users aren't going in and testing at the same time, so there's no more than 2 users on a workstation at one point. But then that way it will just alleviate, because we've run out of time today, I'm not able to show those transmission spans until tomorrow. So if you did have any of your team from transmission that wanted to start playing with data, they can go here, review. As long as they release and don't submit, it's not an issue.
Yeah, so right now we will be just releasing all the files that we'll be working on the span review as such. Tile review is something, transmission project, we still waiting to have tomorrow's session, so we will not focus on that right now.
Correct, yeah.
See the span review part, whatever you have shown, you'd like to open up multiple tiles. Maybe we will release all of those tiles. We'll just experience what kind of tiles that we come across as such, and then probably what all work that needs to be done based on what things you have shown so far. And then probably, if we have more questions, as we have a session tomorrow, we can cover those questions that we come across today, and we can take it forward from there. If needed, probably can have another round of session after 2 days or something like that.
Sure, that sounds good, Nozer, no problem.
Yeah, have a play around with the software, Nozer. I think for both
software teams.
Software
is more or less the same. It's only the additional functionalities and the specs we need to really work on, because we have seen the software now. We have most of the guys who are there on this call have actually had good hands-on with the software. So it is more of a spec, and what needs to be done with the data is something we need to figure out.
Yeah, and it'll be very similar for tomorrow. It's just that they're transmission lines, so it's going to be larger and a different way of going about it. But it's basically span review as well. Okay.
Not a problem.
Yeah.
It would have been good, Tad, if we could have used all these logins for either projects, because it just gives us more flexibility to use the workstations.
Yeah, so you can use those logins. It's just that the software on those first 10 workstations is specific to span review for 8785, and the remaining 20 is for 3132. But the logins can be used across different projects. Does that make sense?
Not really. I'm not clear with that.
Okay.
What I'm trying to say is, we could use either of the projects using those logins. That's what I was trying to say.
Yeah, sorry. I suppose there's been some miscommunication. So the spreadsheet that I gave you, they're the logins, and you can use that to actually get into any workstation, those logins, so those usernames and passwords. But the actual workstations, so VWSAG21 down to 30 can only be used for 8785 because the software is on that workstation. The 8785 software is on those workstations.
Okay. We will check that out.
Yeah, have a look at that spreadsheet.
Yeah.
Hopefully it makes more sense, but I can always we can talk about it more tomorrow as well.
Yeah, certainly. I'll try to put more people to these machines, and probably that time what we see on the screen will come across, and then probably we'll have a better feedback mechanism.
Yeah. Okay.
Yeah.
Any more questions, or we'll leave it for today?
No, I think we had a lot of information from Alois, and we have to have a few almonds, and we have to take few almonds today and recollect everything.
We need to digest those, yes.
You might have not had your breakfast. You need to first have that.
Thanks Alois and Tad, and we will put some time today and try to recollect what you have said today. And if you have recorded the session and upload it, that would be really great.
Okay, great.
Yeah.
Well, good luck today.